I know that the concept will be quite confusing, okay, about having work done, okay, whether the internal energy equals to the heat change. So in this videos, I'll just give you a few more examples so we can consider them together. So first of all, okay, you can see that this one is an open system. These three questions is under constant pressure. Open system, okay, open system. Imagine, okay, just like a flask. Okay, and then you got a piston like this. Is that right? Okay, so this is an open system. We just check, okay, the number of mole of gases on both sides. So this one will be 0. This one will be 2. Okay, so therefore we'll have increase in the number of mole of gases, increase in the pressure. So therefore we'll have a work done here. You have a work done here. Because you have work done here, okay, so therefore the heat content will not equals to heat change, not heat content, will not equals to the change in internal energy. Change in internal energy. Okay, and then the second one, okay, this one have 3 mole, and then you got 2 mole. You got a negative change in work done. Okay, we do work done here. Okay, pressure decrease in the process. So therefore, again, this one they won't be equals. Heat change will not equal to the change in IE. Okay, the third one, okay, you can see that, okay, here, okay, we have no gases, okay, but we got 1 gases here, so we do have work done here, okay, and pressure will increase, so therefore they won't be equals as well. Okay, so for this reaction, okay, these two reactions occurs under a constant volume, a closed system. So imagine we got a flask, and this is a closed system. That means you have a stopper here. Because there is a stopper here, there will never be, you're not going to blow out the stopper, okay? You can't push it back, okay? You can't remove it, things like that. So therefore, you never have any work done here. If you have no work done here, the heat change will always equals to the change in internal energy. So for this one, okay, even this one will be 0, 0, and this one you have 9 mole, while here you got like 10 mole. Okay, so no matter there's a changes in the number of mole or no changes in the number of mole, all the times, okay, because you have no work done to the surrounding, heat change will always equals to the change in internal energy. So last case, okay, it will be a open system. Again, open system means it have a constant pressure. Okay, so in your mind, okay, you should have a flask, okay, there will be a invisible piston here. So we just count the number of mole on both sides. So this one will be 0, this one will be 0 number of mole of gas. So this one, no work done. Okay, no work done, that means, okay, the heat change will equals to the change in internal energy. Okay, so this one will be 4 mole, and then you got 2 mole here. Okay, so there's a change in pressure, so therefore there's a work done there. Okay, and heat change will then not equals to the internal energy. Okay, so this one will be 0, and then here you got 10 mole of gases. So therefore you got work done produced, pushing the atmospheric pressure back. So therefore the heat change is not only equal to the change in internal energy, but also included the work done to the surrounding. So this one will be 9, this one will be 10. Again, you got work done here. So therefore the heat change not equal to the internal energy. Okay? Okay, last 2 questions. Okay, you may pause the videos and have a look or see which one or the heat change will equals to the change in internal energy. Give it 3 seconds. Oh, okay, so this one is an open system, it's a constant pressure. So you have a flask, okay, constant pressure. So you may do work done, okay, on the atmospheric pressure. So we just check whether do we have the number of mole changes in the process. So on the left hand side, there will be 1 mole of oxygen. Well, on the right hand side there will be no gases. So therefore you will find that the number of mole of gas, okay, in the process will just reduce. So therefore we'll have a negative work done on it. So we have work done on it. So therefore the heat change will not equals to the change in internal energy, okay, because it involves work done, okay. While the second one, okay, you can see that on the left hand side there is no oxygen, no gas produced or consumed, while on the right hand side also we don't have any gas, okay. So therefore in process, okay, there should have no work done during the whole process, so the heat change will equals to the change in internal energy. Okay, so that's all for this video. Hopefully, okay, with more examples, you will know when the heat change will equals to a change in internal energy, when will not. Okay, so bye bye.